This is an example of a percent yield problem. We've got 3.65 grams of copper is collected from a reaction between 1.87 grams of aluminum and 9.65 grams of copper 2 sulfate. We want to find out what the percent yield of the reaction is. I think the very first thing I've suggested doing is to identify the actual. Since we are figuring out percent yield, we need the actual and the theoretical. So what I'm going to do is I'm going to identify the actual, and I'm looking at this word right here, collected. That's one of my clue words that tells me that this 3.65 grams of copper is my actual. Probably the next thing I would do is write a balanced equation, since I don't see an equation here. In fact, I don't even see any formulas. It looks like I've got a reaction between aluminum and copper 2 sulfate. So those would be my reactants. So let me go ahead and start with my arrow here. And I've got aluminum reacting with copper 2 sulfate. And this looks like a single replacement reaction. Aluminum is going to replace copper in aluminum or in copper 2 sulfate. So we would wind up with copper getting kicked out by itself and aluminum sulfate. We are asked for the percent yield, and we've got copper, so we know that we're going to be looking for copper as my unknown in my stoichiometry problems, since my actual is copper. So my 1.87 grams of aluminum and my 9.65 grams of copper 2 sulfate are my givens that I'm going to use in my stoichiometry problems. Since I've got two givens, this is going to be a limiting reactant type problem. I need to figure out which one of these is going to produce the least amount of copper, and that least amount of copper is going to become my theoretical. So let's go ahead and get started. I've got 1.87 grams of aluminum and 9.65 grams of copper 2 sulfate. Stoichiometry says I'm going to go from grams to moles, moles to moles, moles to grams, and again I am looking for grams of copper in both cases here, because that copper is going to match my actual. Alright, so let's get started. One mole of aluminum on top and 26.98, I believe. Let me look that up. Where's my periodic table? There it is, aluminum, 26.98, yes. So it's 26.98 grams of aluminum times, in this case I am interested in the aluminum and the copper. So I've got, oh, you know what I didn't do is I didn't balance this thing. Oh, let's go ahead and do that before I jump the gun and get all lost here. Alright, let's see here. I need 3 of these and 3 of those and 2 of these, and I think I'm done. Now I'm ready for my molar ratio. Got to be careful with these. You can't just keep going without a balanced equation. Alright, so we're looking at 2 moles of aluminum on the bottom and 3 moles of copper on the top. They're the two things that I'm interested in. Times, I've got 1 mole of copper on the bottom, and I believe it's 63.55. It is 63.55 grams of copper on the top equals, I'm ready to go ahead and grab my calculator and calculate this. So I've got 1.87 times 3 times 63.55, and I hit enter. I'm going to divide that by 26.98, and then divide that by, oops, you know what, I'm going to hit enter on that, and then divide that by 2, and I get 6.61 grams with sig figs. 6.61 grams of copper. I don't know if that's what I need yet because I'm looking at the reactant that produces the least amount of copper. So I do the same thing with copper 2 sulfate. Got 1 mole CuSO4 over so many grams CuSO4. Go back to my calculator here. Let's clear this. I'm going to make this just a little bit bigger so I can see that a little better. I've got copper, well, let's do this. I've got 4 oxygen, so it's 4 times 16. And then I'm going to add sulfur, which is 32.07. So plus 32.07. Hit enter. And then I'm going to add my copper. So that's plus 63.55. 63.55. Hit enter. 159.62. So 159.62 grams of copper sulfate times, now this case, I am interested in the copper sulfate and the copper. So it's 3 moles copper divided by 3 moles copper 2 sulfate. And then my last step is to convert to grams of copper. So 63.55 grams of copper divided by 1 mole of copper. And I'm ready to grab my calculator, and I've got 9.65 times. I'm not going to do the 3 over 3 because that's going to cancel out. So I'm going to take that times 63.55. Going to hit enter here, and then divide that by 159.62. Hit enter, and I get 3.84 grams. So it's 3.84 grams. This is my theoretical. It's also the least amount produced based on copper sulfate being my limiting reactant. At this point, I can go ahead and figure out my percent yield. Again, it's my actual. So I've got 3.65. You know what, let me do this. Percent yield is going to be equal to actual over theoretical times 100. In this case, my actual is 3.65 grams of copper divided by 3.84 grams of copper. Notice both copper, okay? Both copper. I needed to go to copper with my stoichiometry so that I could make this comparison. Again, percent yield is nothing more than a comparison of what is made versus what should be made based in theory, or based on stoichiometry. And we'll multiply that by 100. That's going to give me a percentage of, well, let's find out. I've got 3.65 divided by 3.84, enter, times 100. and we get 95.1%. 95.1%. This is my answer. Again, I've got my actual up here. Got my actual up here. I've got my theoretical here and my answer here. And I am answering the question of what is the percent yield of this reaction.